I built an LLM Math Roaster. You put in a math problem, it'll score it, roast it, and we'll go through that in just a second. You can actually submit a custom problem. So if you have your own problem, you can simply do that.
It's awesome.
Built this week, breaking it down. Built this week, we show you how. A fresh idea, a clever tweak. You locked in, you built this week.
Hey everyone, and welcome to Built This Week, the podcast where we share what we're building, how we're building it, and what it means for the world of AI and startups. I'm Sam Nadler, co-founder here at Rise Labs, and each and every week I'm joined by my friend and business partner co-host Jordan Metzner. And this week we have a special guest from Axiom Math AI, Carina. Hello, Carina, and welcome to the show. If you don't mind, give us a 1-minute intro about who you are and what Axiom Math does.
Hi, Sam and Jordan. Hi, everyone here. I'm Carina, founder and CEO of Axiom. At Axiom, we are building a self-improving, super intelligent reasoner, starting with an AI mathematician, the AI that can do really good math. It can prove theorems, it can formulate new problems, and it can discover new mathematical objects like graphs and fancy functions that show up in important partial differential equations, etc. Yeah, great to be here.
Super exciting topic. We're going to jump in just to cover the high level docket for today. We're going to go into a cool tool that Jordan built to really put the current LLMs up against each other for math proofs. We're also just going to dive into Axiom Math and your mission and hear directly from the source itself, about what you guys do and how it's all coming together. And then lastly, we're going to cover some of the latest and greatest in AI news. I think some big fundraisers, as always, Bezos' new opportunity, and just what's happening in the last couple days. So with that, Jordan, I'd love for you to walk us through what you built with Axiom in mind.
Yeah. So, hey, Carina, welcome to the show. Hey, Sam, another great episode. Another crazy week in AI, obviously, with the news of Gemini 3 dropping this week and a bunch of other things. So, it's almost never a dull moment in the AI world. When we first spoke with Carina, we talked about some ideas of just building some kind of vibe coding applications that could be cool for math and could be even cool for Axiom in general. So I built an LLM Math Roaster. Carina, I hope you like it, but I want to show you how it works. And it's productionalized, so it works pretty well. Okay, cool. So I have it in light mode and dark mode. Pretty cool, right? All right, I have some style. All right, so dark mode is better for math, right? I feel like that's a little on math.
No, well,
light
maybe.
Mode? Light mode? Okay, light mode for math. All right, so here's how it works. So I collected a bunch of different problems of different levels of difficulty. And then I have different models. I have Gemini 2.5 Pro, GPT-5, Claude Sonnet 4.5, and Grok 4 Fast. Now, I wanted to add Grok 4.1 and Gemini 3, but these models just came out yesterday and I don't have API access yet. So, and even 5.1 is out, but I just didn't get it to put it in time. But before I run it, let me just show you a little bit about what the application does. So you put in a math problem, it'll score it, roast it, and we'll go through that in just a second. You can actually submit a custom problem. So if you have your own problem, you can simply do that.
That's awesome.
We have the history. So of all the maths problems that I've run in the past, we can see how well they've performed. And then I thought that'd be fun for your team, but I did a little extra and I built a little API. So what your team can do is generate their own API key, and using my API link here, they can pass in a request of a question. And then what they can do is have in the background it run, have all the models go do their own results, and then they can compare them.
Oh, that's really cool.
Let's jump into it. So first is, I'm okay at math, but I'm certainly not at your level. So the first thing I wanted to do was just build something really easy to prove whether or not my model works. So I did something, let's just, 2 + 2 = 4. And at this type of math is, probably at my level, and I think I can solve it. So what I have all these models doing is I have Gemini, they're writing kind of a lean proof. You can see the response times from each of the models.
Oh, wow.
We can compare the results of each of the models. And then, obviously you have this problem, which no model knows which model is smartest. So I chose ChatGPT. So ChatGPT will then evaluate the responses from all of the models. Let's just get this finished with 2 plus 2, and then we can go into a more complicated question and see how well it does.
Yeah, it's great. Ooh, evaluating.
It has to get process each one of these against like the core source. So, ChatGPT's feedback is that all of them are correct. Okay, great job. So fantastic. 2 plus 2 equals 4. All models know that. I think we're on good shape. So far, we've basis of truth, right, Carina? I'm not a perfect scientist, but, I know a little bit. I have a few different problems. Maybe you want to choose which one. I have...
Let's do Fermat little theorem.
Okay, fantastic. So that's considered an intermediate problem here. And here's the problem. For a prime number, p and any integer, a non-divisible by p, we have a to the p minus 1 equals 1 mod p.
Right.
Provide a formal proof in lean 4 syntax. So I just read that out loud just for the audience, So first, let's roast the LLMs. So now we'll have the LLMs. This is going to take a little bit longer, so we can maybe chat in the meantime.
It's fascinating. There's so many Fermat theorems. I think when I selected it, I was actually having something else in mind. But yes, I think this one is the Fermat little theorem.
But ChatGPT told me that it is when I built the app. So as I vibe coded this thing, I'm pretty sure it is. But the good part is that you can kind of submit, whatever formula you want. What I tried to do is get a collection of about 10 problems of different difficulty so that I could test the application and see kind of how well it does. The easiest one was Pythagorean theorem. And then I felt like, that's even like too difficult just to check, basis of truth. That's why I built the mathematic one, just to check, if everything's working essentially.
Yeah. And that's for lean, so it's generating...
it's going to generate lean response.
Wow.
We're
not seeing the lean.
Okay, cool. All right, so here we go. So here's Gemini Pro. Here's the response. Here's the theorem. Here it just gives the... here we'll provide both versions of lean. Okay. Here's GPT-5.
No, that is lean. I haven't seen lean in the Gemini Pro one yet. If you scroll down, the first one.
It says it's below. Let's keep going right
here. Got it.
Right here. Cool. Yes. All right. So we got import math lab, right? So we've got like these different ones. Now what we can do, first we can compare the results. So we can just review them all side by side. And then we can judge the proofs. I think that's the way to do it. We have 2 ways to do it, actually. This should score it. Yeah, so then it'll judge all the proofs.
Mm-hmm. We could also, take that lean proof and then put it in lean lang and and see if it compiles, which should be hopefully be more painless than having an LLM judge.
Yeah, sure. So we can take I don't know which answer we want.
Probably wouldn't want to take the lean, just start with import MATLAB.
Yeah, got it. But I'm saying we could just pick which one of these answers we want, and we can go into a lean editor.
Probably the entire thing.
Mm-hmm. Yeah. Okay, let's just let the judging finish and let's see how well that does. It's just a really cool way to compare any type of multi-level LLM results against any data set, right? And in this case, I chose lean in math. But, this could be a lawyer writing a contract and sending it out, amongst all 4 and asking them all to bring back, which contract is the best. So it could be applicable in many businesses, even ones that are outside the scope of mathematics. But
fascinating.
Okay, cool. So I have a leaderboard. It gave Gemini the best score, ChatGPT a 70, and so on and so forth. So
that's weird, don't you think? For number 2, it says it proves the theorem for natural numbers instead of for integers. Yes. Oh, I guess, it just didn't deal with the negative numbers. That's fascinating. Just a close miss. Gemini is 98. Wow. Okay. That's great.
So I think what would be really interesting, Carina, would be is in this type of problem set would be to get thousands, right? And just iterate this over and over again and find out where these models truly fail. And if you do this at enough iterations, I don't know what the right end number would be. But my guess is for each major type of problem set, you'd be able to find the model's weakness pretty quickly in its ability to resolve those types of problems.
That's actually the first thing we did when the office is, still camper chairs and plastic foldable table. It's what we did.
That's awesome. Okay, so anyway, that's my math roaster. I hope you like it.
It's great.
And that's enough about me. Let's jump into Axiom.
That was super cool.
Okay, Carina. So obviously super young entrepreneur, super excited about your new round of investment, but let's start from scratch. Tell us, how did this whole thing come about? What is Axiom and what are you guys doing every day?
Axiom is, I think, the coolest AI for math company.
Awesome.
In my opinion, we are building an AI mathematician, a model that can not only do really well on benchmark problems, those Olympiad math problems that we just saw, but also develops capabilities that are like a research mathematician, including the ability to conjecture, which is to propose new problems, unseen problems, hypotheses. And the same system can then try to prove and verify, in addition to solving these problems. So a prover and a conjecture talking to each other, forming the self-play loop, like we talked about in our vision block. Additionally, this system can also auto-formalize, which is to convert the massive amount of math corpus data into lean, turning math into programming language, which, have a lot of great technical advantages because we have seen reinforcement learning on verifiable domains like coding, having achieved incredible breakthroughs. So by combining AI, math, and programming language, all three pillars together, we believe to see the same sort of step function jump in math capabilities, especially real mathematics, serious mathematics beyond the benchmark that a lot of models have seen.
So that's obviously incredibly interesting. Math obviously historically was run on CPUs, right? So the movement of running math equations onto GPUs is really this big jump, right? And the ability to essentially kind of find new opportunities within the mathematical field. Is that a good way to say it?
I think it's close. Well, I think we use, a lot of both GPU and CPU in our engineering effort. There's, obviously the large language models part run on the GPU and the lean part, currently compiles through CPU. And there's interesting engineering problem as to how to maximize utilization because there's some sort of dragging it down, in fact, because CPU generally, could work a little bit challengingly with the GPU. But I wouldn't say that the compute part is kind of the bottleneck. I think the difficult part is the data scarcity, which is there isn't that much lean. There just isn't that much lean. And there are more than 1 trillion tokens of Python code, only about like 10 million tokens of lean code. That's a 100,000 times data gap. So that's, I think, what is really, really hard.
Yeah. So, speaking of that, how I guess like artificial data becomes much more important in generating artificial lean problems.
100%.
If that becomes, more critical in sourcing the data, because you can't just go to a library and buy, a 1920s book on lean, right?
Well, I guess a lot of the companies I know, especially some Chinese companies working on this, are having a massive number of like lean data labelers, lean programmers, to try to generate human data. Of course, that's very expensive. It doesn't scale as well. We have where both data beds own synthetic data generation, both by converting the informal data that already exists, scrape them and, really augment them in a way that makes sense to convert to lean, auto-formalization. We also have other efforts. So given formal math data already in lean, and that's your seed data, how do you make that 1,000 times volumes larger?
Yeah. Okay. So speaking of lean, now that we have AI and everyone has AI, and obviously it's almost like for mathematics, kind of the jump of like having a calculator versus not having a calculator. Is lean now being taught in these mathematics, educational programs, and are students like writing their math, theorems in lean now, or is that still too early and we haven't gotten there yet?
That's a great question. I think a lot of universities are teaching lean. I know a couple of universities in the States, like I know University of Washington, Professor Joe Alper, in the math department is teaching students lean. At CMU, there's a really great lean community. Professor Jeremy Aviga, Professor Sean Volek, and others are teaching students lean. Stanford, has an automated reasoning lab by Professor Clark Barrett and other folks. And they have, TAs that are grad students, teaching students lean. There are many universities in Europe, in the UK, that are teaching students lean as well. In fact, lean started, not lean, but the MATLib, the math library, started as a teaching effort at Imperial College London by Professor Kevin Buzzard. He wanted to teach his students who are enrolled in his introductory level, freshman level proofs class to write better proofs and to train them to think rigorously. So he gave these students who might, be a little bit behind on proof writing the exercise of formalizing everything in lean. what he found is actually it's not those students as his audience, but the students who already don't need the class that, they are very much advanced grad classes takers. And these students, because they are bored and they have nothing better to do, would love to join the effort of formalizing the undergrad corpus of math in MathLib. And 2 or 3 of them are actually currently working with Axiom. Some
Awesome.
of them are like my closest friends over like the last 5 years that I met via MIT Imperial College London exchange program. So really sort of great to have these lean native students and now like they're PhD students and some of them have graduated from PhD. That was like 2019, very early on.
Awesome. How these like LLMs compare to like figuring out math versus like what you guys are doing? Because I think that's like, this is the whole clip of like what's exciting, right? Like if anybody doesn't know about math and they have no idea what you're doing and they're just like a layman who's into tech and AI and they say, okay, what is this? What's the difference between this and ChatGPT? Like what's the difference between like an LLM and what you guys are trying to do?
Large language models are doing math in the informal space. They produce proofs in natural language, that is English, and they will give you a multi-step, reasoning traces if they're DeepSeek, but they will only give you, say, like numerical answer if you're, ChatGPT. And the numerical answer is a verifiable output, which is something that you can, grade, like 971 is 971. The problem is without the sort of very detailed step-by-step deduction, it's hard to verify all these intermediate, reasoning traces. So, it's very difficult for an expert or a layman to know whether there might be a hidden bug, among like a 3,000 line math proof. On the other hand, what Axiom, the informal formal hybrid prover system we are building is to make sure that the output we give are programmatically verified. There is a LIM program underneath it and the LIM program is executable. So in a way, we do not need an LLM as a judge or a human judge. We just run it like you run a Python computer program. I think that's the biggest difference between these formal models and the large language models. In the formal model space, we know that Google DeepMind Alpha Proof system, the system that got silver medal, actually 1 score below the gold cutoff, is a formal system. This year they have the Gemini system, and also OpenAI has the Strawberry Team's IMO team. These are informal systems that got really good scores on IMO. Difficulty is IMO and other Olympiad math benchmarks sort of have a curriculum, a set sort of syllabus of things that they're testing on, which limits their search space quite a bit. When the proof gets very complex and multi-step, requires really hard math capability, and we believe that formal system going to be extremely helpful in continuing to scale on those harder problems.
That's so cool. Obviously, math's the backbone of kind of all technology. So it seems like there's some, mathematical breakthroughs on the edge here that, once these things really get their power, they can really turn out some new opportunities. That's super cool. All right, Carina. Well, thank you for telling us about Axiom. Thanks for joining us. Let's talk a little bit about the news for this week, as it's been another crazy week. Gemini 3 just dropped. I don't know if you've tried it yet. I downloaded Anti-Gravity, the new Google code editor. Lots to tell you guys, but I'm being throttled everywhere. So, Cursor, I can't get Gemini 3 to work. I can't get Gemini 3 to work in Anti-Gravity. I burned all my tokens. So, I'm munching tokens all night long, pushing Gemini 3. But I've been incredibly impressed with its performance for coding and design taste. Also much nicer.
We like Gemini 3. It's also like so much cheaper to run compared to like GPT. One thing that's very interesting is we, on a certain benchmark, I can tell, which one. And our model actually beats Gemini 3 in math improves yesterday.
I know Gemini 3 has been outperforming almost every LLM on the market in terms of test scores. I tried to use it quickly this morning to build a personal meditation app, and I bumped into some hiccups, but maybe it was user error and not the model.
It got 100% on AIME 2025, which is the high school level. So it's 3 levels before the IMO. So if you win AIME, you will go to US AMO, and then you'll go to MOP, and then you will eventually go to IMO. But it got 100% on. Yeah, that's fascinating. but 100% just code execution shows how important the
code is needed. Yeah.
The tool is important.
Well, yeah, it says without tools, it got 95%. So, obviously that's a significant improvement.
That's odd because it has it has 20. Well, I guess that's odd because it has like the number of AIME problems is 25 problems.
Well, if you compare it to Gemini, it looks like to 2.5.
15 problems. So there are 15 problems on the AIME exam. So 95% is like, got one wrong.
Yeah. So they got an 88 last time. So they probably got 2 wrong without the tool. Yeah. Pretty cool. But maybe it's calculated differently because Sonic got an 88. They got an 88.
I guess it's like,
iterations. Iterations probably.
Yeah, past K.
Okay. But anyway, Gemini, super cool. So, I just think this is interesting. The Gemini model for a lot of reasons. I mean, one, this is the first, real big model coming out of, one of the type 3 hyperscalers, the Amazon, the Google, Microsoft. So far, all those models have been behind, pretty much Claude and Anthropic and OpenAI historically. And this is a big leap. Google has a lot of money and a lot of servers and a lot of warehouses and a lot of products to inseminate, Gemini 3 Pro into the products from, Google Suite to search to YouTube to ads. I mean, I don't know, big opportunity. Yeah.
650 million monthly active users across search, the Gemini app. I mean, that's an insane amount.
Yeah, insane amount of users. Obviously, we saw this week Warren Buffett made a massive investment in Google. And I think if you saw the videos of, I don't know if you guys saw the videos from Anti-Gravity, the launch of the code editor, Sergey was front and center, So yeah, good. I mean, this is about CEOs getting back into the driver's seat. So why don't we jump over to story number 2? Because that's another CEO getting back into the driver's seat. So Jeff Bezos is starting a new AI startup called Project Prometheus. He's going to be the co-CEO. To me, honestly, this just seems like Amazon doesn't really have access to, a foundational laboratory like Microsoft does with OpenAI, and they're trying to build their own. I mean, it seems like Google has DeepMind, and Microsoft has a relationship with OpenAI, and Amazon doesn't really have a stake in the ground. I don't know. What do you guys think about this?
Yeah, I don't know. To me, it's exciting that Jeff Bezos is, coming out of semi-retirement and, taking an operational role. I would argue that, he was the best CEO of the last couple decades. So to get him back into a driver's seat, I think is super exciting.
Yeah, I think this is doing like physical science space, so kind of like a lot of real world testing, AI for science. I'm quite excited about that part. Doesn't seem like, like an OpenAI style, like foundation model lab, but more like applying the theoretical findings and try to figure out how to, deal with messy real world data.
Exactly. Hard to say what they're going to do. Obviously, they brought over Bezos from Verily, obviously, who was in the biotech startup at Google, or Alphabet per se. I think overall the trend is that you're getting, these billionaire CEOs who, could be on a beach, or executives or retired per se, could be on a beach or whatnot, but they're coming back to build because, we're in a new build era, and that's exciting, I think. Yeah. Okay. Last story of the day, real quick. Major funding news from Suno. I don't know if you've used Suno, Carina, but I love to use Suno. I find it to be so fun. I think it's a great party trick, but Suno raised a $250 million Series C from Menlo at something like a $2.5 billion valuation. I know we've talked about them a few times on here, Sam, but curious your
Carina,
thoughts.
Suno allows you to quickly generate like highly produced music from a single prompt. And maybe to end out the episode, we'll have an Axiom themed song that we can layer on here, but it's a really fun tool. We with a quick prompt about Carina and Axiom, we could have a pop song, a reggae song,
Oh no, please don't do that.
an EDM song, you name it. We could have Axiom, prove out its math problems in song. Theoretically. No, I'm just joking here, but it's a fun tool that we like talking about. And in fact, like the song of Built This Week, our podcast we created with Suno.
Yeah, I remember playing with Suno. It's amazing that I don't know anything about composition, but maybe there's some melody I want to turn it into reality, which, at one point I feel like when the AI gets really, really good. And, people who are hidden Ramanujans who have mathematical creativity, but having never sort of been trained to do formal proofs could probably, use the Axiom tool and get a actual theorem, just like music and artist creators using Suno.
Yeah, totally. We covered on a previous episode, there's a new programming language where you can program music, and obviously music at the end of the day is incredibly mathematical. So it'll be interesting how, maybe with some new math inventions, we can invent some new styles of music.
Most of the double major, or like the humanities, social science classes, the math majors at MIT take are music, actually, music theory.
It's incredibly mathematical, and, doesn't really matter like what instrument you play. The more you learn about the instrument, the more you get into the, learning about the triads and the triplicates and, how the notes and chords are created. All right, Carina. Well, this was a great episode. Thank you so much for joining us. Sam, this was awesome. Love to learn about Axiom, talk about math, build some new tools this week. Obviously, Gemini 3's kept me up all night. I don't know about you guys, but I'm going to continue to work on it and play with some new stuff. But yeah, this was really fun.
Carina, thank you. It was a pleasure. This is a pretty big pivot from our normal routine episode. So it's been extremely informative and really appreciate you coming on.
Thank you so much. Yeah, I had a lot of fun.
See y'all next week. Bye.
Built this week, breaking it down. Built this week, we show you how. A fresh idea, a clever tweak. You're locked in to build this week.